Hello, good morning, year 9. Um, we continue our linear relationships. So, last lesson, we've learned equation for a given linear graph and also equation for a given point and its gradient. So just do some very quick review. We've been learning the equation from a given graph from which we know that the equation y equals mx plus c, and you need to know the meaning of the numbers in front of m and also the number added to the green letter here, which is the y-intercept. The blue letter m is the gradient, and the whole equation can represent a straight line with xy being any point on the linear graph, and this is called a slope-intercept form. Just have some very quick review of the question we did last lesson. So, for example, if I give you the gradient and y-intercept, just like part A, then you can just use the form and fill in the numbers into m and c, then you will have an equation for a straight line. For part B, again, you know the gradient is -1 and it passes through origin, c being 0 because y-intercept is 0. Then your equation of straight line would just be y equals -x. Just a very quick recall. Okay, so if you want to know the details, you need to go back to your handout. There are much more detailed solutions there. And more difficult question would be like part C and part D. In part C, you're given a gradient and also a point. So the method is we need to put in the gradient first, but you still need to find the value of C. Then all you need to do is to put the point given, which in this case is 2 minus 4, into x and y. So remember, 2 is the x coordinate, so you need to put into 2, and -4 should be put into y. And the purpose for doing that is to find the value of c. So when x equals 2, y equals -4, that just means we're going to substitute the x value and y value into the equation to find c. Okay, and c equals -3. Don't forget to write the whole equation. In the end, you need to put that minus c back into the equation. So the answer must be in a whole equation in the exam. You can't just get me C and leave the question. In that case, you will lose mark. Okay, another one. So remember, x-intercept 5 is not y-intercept 5. If that was y-intercept 5, then you can say c is just 5. But when x-intercept is 5, that just means you have another point 5, 0. So you have to do the thing similar to part C. When x equals 5, y equals 0. So you put numbers into your equation to find c, and after that you just put c back into equation and you get the answer, right? Okay, here are the questions. Ask you to do it as homework and some class practice as well. Okay, so if you haven't finished, you can finish at home. Okay, that's what we are going to do today. Today we are going to do finding equation for a table of points on the graph. So I ask you to have your handouts. So the handouts we give you on Thursday, and so you should have the handouts with you. And please turn to, let me check which page isn't. Sorry, I forgot the page number. Okay, that should be page number 5, the handout you used yesterday. Please turn to page 5. Okay, when you are ready, if two variables are linked by a linear rule, then as one variable increases, the other variable either increases or decreases at a steady rate. The key here is the phrase steady rate. And one way to give you a linear relationship is in a table. So it's a tabulation of points or values for two variables, x and y. Normally, we will put the independent variable x on the first row and the y, which is the dependent variable, on the second row. How can we see the pattern of the two rows? If you want to check whether that's a linear relationship, you can check when x is increased by from 0 to 1 by 1. I put plus 1 here. Actually, that means run if you want to refer back to our previous study. That's what we call run because that's the increase in x. So how about y? From 5 to 8 increase by 3. Does it mean every time you increase x by 1, then y increase by 3? You can't conclude that at this moment because you need to check more pairs of the points before you can conclude. So let's track the next two pairs of the points. From 1 to 2, again, x increased by 1, and then y increased by plus 3. Oh, it looks like the pattern is still there. How about the last pair, from 2 to 3? Okay. So that means when x is increased by 1, then y is always increased by 3. And this is what we call a steady rate. Steady rate means the rise over run is always a constant, or the increase in y divided by increase in x is always a constant rate. So from the table, you can find the gradient. Gradient equals rise over run. Rise means the change in y. Run means change in x. So plus 3 divided by plus 1. So it's 3. And also, how can we find the y-intercept? Remember, y-intercept is the point where the line cuts y-axis. So you can find that from table. Sometimes, not always, but in this case, you can find the y-intercept from table. Where is the y-intercept from the table? So in the table, you can see there's a pair of points. When x equals 0, y equals 5, and that would be your y-intercept. So x is 0, y equals 5. So c equals 5. Okay, so y equals 5, when the y-intercept is 5, in terms of the symbol in the equation, then you would say c is 5. Now we've got m equals 3 as gradient, c equals 5 as y-intercept, then you can find the equation. That's what we are going to do today. You will be provided a table. From the table, you just find the find the rate of change. You need to track, of course, the rise and the run, are they in a steady pattern? So if there is a steady pattern, that means that there's a steady rate, then you can find the gradient. And also you need to find the y-intercepts, and then you put two things together, then you will have the equation. So the final purpose, the final goal is still to find the equation. Oh, okay, so let's go back to our handouts. All right, so here is example 3. So I'm going to work on this example to find the rule connecting x and y. Rule means what? Rule just another word for equation. And the equation we're using is y equals mx plus c. That's a linear equation. Of course, you know all the tables I'm now providing should be linear. But in the exam, there would be nonlinear relationships as well. So you can't assume all the table, all those tables contains a linear relationship. You need to check for the linearity. Okay, how can we track the linearity? First, you need to see the change in x versus the change in y. This time from 7 to 5, so it means a decreasing, isn't it? Unlike the last example, that was increasing. So this one should be -2. Again, 5 to 3, you need to check. Okay, so you see this is a linear relationship because when x increased by 1, y is decreased by 2. And it's always true because the pattern you can check for the last pair to make sure. So it's pretty sure now. It should be a linear relationship. So you can write. So you can write y is in a linear relationship with x. For linear relationship, we can talk about the gradient. Gradient is rise over run, and rise over run means the change in y divided by change in x, which is now -2. And how about y-intercept? For y-intercept, you need to find the pair of value where x is 0. So that's very important information. You need to find a pair of value where x is 0. Do we have such point? Yes. When x is 0, y is 7. Okay, so y-intercept is when x 0, y is 7. Therefore, we can say c equals 7. Now we've got m and c, so we can find the rule or equation. The rule is just y equals -2 times x plus c, which is 7, and it's done. Okay, so if you need more time to copy the question, please raise your hand and the teacher can pause the video for you. We might just pause the video for like 2 minutes for you to copy the things, right? Okay, please pause the video for 2 minutes. Thank you. Okay, so if you finish copying, then we need to continue now. Another example, again, you need to find the rule. The same process, I'm doing it again. So this time, I will give you a little bit time to try to do it first, and then I follow up. Okay, so first, how can we check whether this relationship in the tables is a linear relationship? Think about this. What should be the first thing we need to do? Some of you might have got answer. First, you need to check the change in x versus change in y. You can't just check for one pair. You need to check for all the pairs of values. So it seems like when x is increased by 1, y is always increased by plus 5. So this is a linear relationship. You can say y is in a linear relationship with x. Then what should be the next thing we're going to do? Refer back to the previous example. Are we going to find the gradient m? What's the formula for gradient m? Okay, rise over run. What do we mean by rise in this case? Rise is always the change in y. It's not the change in x. Don't get it wrong. Some students, they might think x is, in that table, x is above y. So some of them, they make mistake by putting the change in x in the numerator. I mean, above in the fraction, and the change in y below in that fraction, which is wrong. Remember, rise is always about the change in y. So you always need to put change in y in the numerator, and change in x, which is the run, in the denominator. Don't get these two numbers. Don't swap these two numbers. All right. So this will become plus 5, or just 5. What should be the next thing we're going to find? Refer back to the previous example and think. Must be y-intercept. How can we find y-intercept from the above, from this table? Is there any points that we can use to find the y-intercept straight? What do you think? No, there's no such point. Okay, so you can say we don't know. We don't know y-intercept, unlike the previous case. The difference between example 4 and example 3 is that in example 3, there was a pair of points with x equals 0, y equals 7. So In example 3, y-intercept is given, but not here, not in example 4. It's not given. You don't have x equals 0. How can we find y-intercept? We can use our previous method. If we don't know it, we just put y-intercept as c temporarily. And you write the equation y equals 5 because we've already got m as 5. Let me emphasize the use of equation a little bit. Mx plus c. And I just write 5 to replace c, but still I don't know c. Let me continue here. How can we find c? If you still remember last time, if we want to find c, all we need to do is find a pair of x value, x, y value, and put them into the equation, and that will do it. So let's just pick any pair. I might just use the first pair. We use 1, 2 as a point on the line or in the table. So that means when x equals 1, y equals 2. So I could put y equals 2 into equation, x equals 1 into equation. I make it a bit slower. So I need to shift the 5 to the other side to find c. C will be a minus 3. Now we find c, and also you've already got m, so our rule would just be y equals 5x minus 3. Right. Please pause the video for 3 minutes this time, and please copy the questions. Just remember, if we don't know c, it's okay, just a bit more difficult than the questions with the y-intercept given. If you don't have the y-intercept, that's okay. You just rewrite the equation with c unknown. Just like in example 4, I rewrote y equals mx plus c. Then just choose any pair of points. Like if you use 1, 2, you just put that x equals 1, y equals 2 into the equation to find c, just like what we did before, and you will get c and then the equation. Another challenge here. This time, again, another rule. Of course, we will expect this one as another linear rule, but we still need to check. Plus 1, minus 1, always be careful. If y is decreasing, minus 1, plus 1, minus 1. So that means when x is increased by 1, y is always decreased by 1. It's a linear relationship because that's a constant rate between the change in y versus change in x. Let's find gradient. Rise over run. What will be the right? It's always changing y. Don't make it wrong. And m is not difficult to find, to be honest. The problem is, do we have y-intercept in the table? No. Again, we don't have y-intercept in the table, just like what happened in previous example. So to find the y-intercept, we don't have direct information. So you put C, we don't know yet. And what should we do? Okay, so here is a big process. You need to do it by yourself and try to see if you have already got it. If not, that's okay. I'm going to tell you a few minutes later. But I would like you to try first to see how much you've learned and how far you can go to find the rule. Is that okay? Can please the teacher pause the video for 5 minutes, and students, please can you try to work. If you don't really know what's happening, look around. If someone smart enough, they've already got the idea and they can give you some insight. Okay. 5 minutes. I guess some of you have got the answer. So what can I do? Just like the previous question, we don't know C, but we know M, so you just put things which you've already known. Minus 1 times X plus C. To find C, just pick any point. I guess most of you use the first pair, so I would try to do a little bit variations here. So I would try to use 5, 10. How about that point? It doesn't matter. Any pair in the table would be fair, would be okay. So I just verify that with you. So if I use when x equals 5, y equals 10, I use 5, 10 as the point. I choose. Then I put 10 there and minus 5 plus c. So I put minus 5 to the left hand side. C would be 15. If you use the other pair, you will still get C equals 15. They must be the same. If there's something wrong, then check your computation. The rule is y equals minus x plus 15. That would be the answer. Right? If you need to copy, raise your hand to ask teacher to pause the video for you. Otherwise, I would just move on. There are two modeling questions in, three modeling questions in my handouts. Okay, so it depends on you. If you want more time to consolidate your understanding first for those for using the table to find the linear rule, you can just let the teacher know. Then we can pause the video for you now, and you can just work on some of the questions in that practice 7. You can try some of the questions here, like you can do that first. What you think tables, you'll be fine. Then in my video, I just continue with the modeling questions. They are more interesting. Okay, that's what I'm going to do. All right, so modeling question is about some daily life situation which is given the two quantities have a linear relationship, and they give you some pairs of values, and you need to find the equation and also the certain pair of values which are unknown. All right, so let's see the question. It's known that the amount in Jack's monthly bill, $C, for mobile data. Okay, the first quantity is amount in Jack's monthly bill. Monthly bill. So this is C. Varies linearly with, you see the word linearly, that means a linear relationship with the data used, the gigabyte. So you see the another quantity, there must be two quantities with the data used is D. This in gigabytes, that's a unit, is not that important. So there are two quantities, two variables, I should say, sorry for the language, okay? Should be two variables. One is amount for monthly bill, which is C. The other is amount of data used from Jack. Then the question will provide you some figures. On January, Jack used 12 gigabytes and received a bill of $16. And then you need to refer these two given numbers back to the data. Back to the letters. Sorry, not the data, letters. How about that 12 gigabytes? That should be the data. So that's one of the D value and received a bill of $16. That obviously should be a C. That's on January. Then there should be at least another pair. On March, it was 15 gigabytes for $19.6. Again, two numbers. That's a D. Determine an equation between the two variables C and D. To find the relationship between two variables, equation, or to find the equation, first of all, you need to find the relationship between two variables. And we know the relationship is linear relationship. That's the relationship. And to deal with two pairs of values, you need to have a table. So let's try to draw a table here. To draw the table, I need to have how many columns? One column. Sorry for the poor drawing. And then you need to decide which letter you need to put in the first row. Theoretically, it doesn't matter. But normally, we will put our X variable in your first. But they are not using X and Y, aren't they? So you need to think the first row should be independent variable. That's I can't say it's a must, but it's just a convention, if you can understand. Convention, that means the normal way we do things, convention. independent variable. And the second row should be dependent variable. So what's the difference between independent variable, dependent variable, which means some of you have learned science, so you should understand. Normally, dependent variable depends on independent variable. It is a kind of strange explanation. Okay, so you can think like if I say the amount in the monthly bill C depends on the amount of data used. That sounds quite good, right? So, but if you reversed, you say the amount of data used depends on the bill. It sounds a bit weird. So normally we would say you need to use the data and then you see how much, and then you have a bill which depends on how much data you've used, right? So should be the data comes first. So data should be independent variable. It happens first, and then the cost comes later. The amount of bill comes later. So you put D here and C over here. So independent variable is D and dependent variable C. So in the exam, if you make that mistake, you put C in the first row, would that be a disaster? Normally it won't be. You still get some minimal result, but you need to be very consistent throughout your calculation. All right. And D is our data used, which is 12 gigabytes, and the course is 15 15 gigabytes and 16.6, right? Then we don't need to check whether they're linear because it's given they are linear. Okay. And because we know they are linear, but we still you still need to find the gradient. We can so I rephrase that. Sorry. So since we know it's linear, it's important for us to find the gradient, right? To find the gradient, you need to find the rise over run. Right now it's a bit strange, so we are not using xy, so let me remind you, the first line is just x, and the second line just like y. Plus 3 here, plus 3.6. And you can say, since the various the is in a linear relationship with C. Therefore, we can say we can find gradient equals rise over run, which is 3.6, 1.2. And we don't know C. We don't know C. Y-intercept, we haven't got C. So you need to find C, right? Just like what we did before. But this time we're not using Y and X anymore. We use Y is like our C, so C equals, let me still write the Y equals MC for some of you if you feel difficult to understand. So normally we use that kind of terminology, okay? So that's lowercase c, which is different to the uppercase C. But now your Y is capital C, and M is 1.2, and your X is uppercase D. You still need to find that lowercase c. All right, and how to find that lowercase c, which is a y-intercept? you need to substitute a pair of value like d equals 12. When d equals 12, the capital C equals 16. So you will have 16 here, 1.2 times 12 plus C. Sorry about the tight spacing. 14.4 here plus lowercase c. Oh, I hope I got more space. And 16 minus 14.4 equals lowercase c, and lowercase c just means this equals 1.6. Oh, good. Therefore, it's still, oh my goodness, still part A. How can I create some space to do part B? Don't worry, I'm going to get the space. I think I draw that table too big. All right, and the rule is capital C equals 1.2 capital D plus 1.6. Oh, it's very poor spacing here. Let me all right. I just need to create some spacing on my screen. Okay, so around plenty of space. I'm going to write the answer here. So my rule is C equals 1.2D plus 1.6. So that's the answer for part A. Okay, please 2 minutes. Try to copy the answers. All right, so I need to continue now. And part B is about the cost of bill when the data consumed is 24. So B is about to find out the C, the capital C, when D equals the data used is 24. 24. What's the C value? Then what I'm going to do is just put 24 here. Use your calculator, okay? And you will get $30.40. $30.40. That's the answer. I think the time possibly I run the video too long. I kind of lost track of my time. I hope you still have some class time. Anyway, I'm not going to do example 7. If you have more time, you can do the questions here, or you can try example 7 by yourself. I'm coming back next week anyway um, to check if you've done your homework and also all the work in the class. Is that okay? Okay, thanks for the teacher to help us to run the video and also pause the video. And I hope you guys have learned something today. All right, see you when I'm back. Take care. Bye-bye.